Okay, so let's talk about how we can use extreme values to find different things based on what we're told for intervals. Okay, so let's start with this first guy. So if we say, hey, we're going from negative infinity to positive infinity, so that's going to be this part right here. So we're going from negative infinity to positive infinity. That means that this graph is going up, 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 and it never stops. So do we have an absolute maximum value? And the answer is no, because our y values continue to increase every single time we move further from the origin. But what about an absolute min? Well, that occurs right down here at 0. So if we go from negative infinity to positive infinity, then that is our setup. No absolute max with an absolute minimum at 0. Okay? So, well, what about if we go from 0 to 2? So we're actually going to include 0. Okay, we're going to include 0. We're going to go out here to 2. So we're interested in this part right here. Well, in this situation, we do have an absolute max and we do have an absolute min because we're starting at 0, and that's the low point on our graph. So if we start at 0 and we're at that low point on our graph, then we're right here. So my minimum is 0. And then my maximum, if you just go up right here, let me choose a different color that's not showing up at all. If you go up from 2 to this spot on our graph, then you're going to be at the point 2, 4. And so we'd have a maximum value of 4 when x equals 2. So we can actually, where we're including those endpoints, we have an absolute max and an absolute min. All right, so let's look at something else. What if we said, okay, well, you can not include 0. We're going to parenthesis here. We're not going to include 0, but we are going to include 2. Okay, we are going to include 2. Well, we're back up here again at this fun point right here. We have a maximum value. We're including that. But since we're not including 0, here's what's happening. We're getting close to 0, but we're not touching 0. And so as you get close and closer and closer and closer to 0, you can continue to do that forever and ever and ever. You'll never actually get to 0. So we, in this case, do not have an absolute minimum because we don't have a specific x value that is at the bottom end of our interval. We're not including the 0 in this case. So we can always get close to, but we can't touch. Do we have a max? Yes, we do. It's right here. Okay, do we have a min? No, we don't. All right. Another situation we could have is a situation where we go from 0 to 2, and it's going to look like this. And anytime you have a case where you've got parentheses, we're not including 0, we're not including 2, then there's no way to find an absolute max or absolute min because we can always get closer to those points, but we can't ever touch those points, which means that our y values will always increase but never come to a specific max or min. So those are kind of some different rules on that. Well, here's what the extreme value theorem says, and it ties in with all of this, that if f is continuous and on a closed interval, so think about what we just kind of talked about here, and let's look at this graph. If we have a closed interval on this graph, so I'm going to go from here to here, I have a closed interval, I'm including the endpoints, then f will have both a maximum value and a minimum value on that interval, and it doesn't matter where it's at. So if we look at this graph right here, if we're going to go from here to here, I have maximums, I have minimums. Okay, I've got both because it's closed. I'm including the endpoint. Hey, I can move those around just a little bit. I could go from here to here, okay, which means I've got a minimum here and a maximum here. I can move them to different places. It doesn't matter. If I have a closed interval where I include endpoints, I've got maxes and minimums, and that is what is really important with the extreme value theorem.